Section 3.4, homework problem number 2. So in this section, we're going to learn how to add fractions. Again, a common mistake your future students may make, which a lot of students in my algebra class, not a lot, always we have a few students, they would try to add straight across, say 2 plus 3 is 5, and 3 plus 4 is 7, which is totally wrong. So we need to explain to them why this is incorrect, and also we need to tell them how to solve the problem correctly. Okay, so we're going to look at the example how to add 5/6 and 3/4. So first of all, explain why we add the correct way. So first of all, what's the correct way? The correct way is we have to find the least common denominator. So the denominator 6 and 4, the least common denominator of 6 and 4 is 12. If you want to use 24, that should also works, but that's called a common denominator, not the least. L here stands for the least. It's usually easier if you use smaller numbers, but 24 should also work, but you have to reduce your answer in the end. Now we're going to use the least common denominator, so we may not need to reduce in the end because the answer may be already reduced. And so first of all, the correct way to do it is, so we have to turn both denominators to the same denominator if they're different by multiplying the numbers. So in chapter 2, we learned why 5/6 equals 5/6, multiply both of them by 2, which is 10/12. So we already learned why they're equivalent and how to explain why they're equal. So we do that, turn both fractions, and again, similarly, y 3/4 is equal to 9/12. And after that, we can keep the common denominator and just add the numerators. 9 plus 10 is 19. So this is how it works. But for algebra class, that's all you have to do. But for us, we need to explain why. Why cannot we just add, for example, in this case, 6 and 4 to just get 10? Why do we have to turn them both into 12? So that's the question we need to answer. So when you teach your students how to do additions, you can tell them, give them a reason why you have to change both of them to 12. And what is the logic behind the procedure? Make math joins. So make sure we have math joins. Okay, so when we add them, we first give them a common denominator. Why? So they have like parts. So what do we mean by like parts? So here we have picture to go with the explanation here. So notice that when you draw, so first of all, we're going to use paper strips, what we call strip diagram, and to demonstrate both fractions. So 5/6 will be, we draw a hole, and then we which represents, well, the first hole, this you may skip it as long as you make sure for both fractions you use the same hole, because whenever we add fractions, we're adding these two fractions out of the same hole. They cannot be out of different holes. So we are going to divide the first one into 1, 2, 3, 4, 5, 6 parts, and we're going to take 5 of these, so that will give us 5/6. So 1, 2, 3, 4, and take 5 of these, so that's 5/6. Now for the second fraction, so this is demonstrates, if I highlight all of these, shaded, so that's 5/6. Next, 3/4. We make sure you take exactly the same length. Like, see, these two are identical, and because they're both out of the same hole, we cannot add fractions out of different holes. So we are going to divide them into 4 equal parts and take 3 of these. So up to this point. Maybe just do this, will be a little clearer. Okay, so now notice if we try to add them, and if you look at each pieces, the yellow one, the orange one, and the blue one, see, this is 1/6, how big it is, and this is 1/4, that's how big it is. So when you add 5 smaller slices like this and 4 big slices like that, we cannot add them. We cannot say we have 8 of what size, because they have different sizes, right? So you cannot say I have 6 because these are not 1/6. You cannot say you have 8 fourths because these are not 1/4. So you have 5. If you remember the definition, that's 5 parts, each of size. I'm just gonna put of size 1/6, but this one is 3 parts, each of size 1/4. So if you add them, you cannot say 5 plus 3, it's 8 parts of which size, because they have different sizes. And which one do you use as your denominator, as your size, which denominator indicates the size. We cannot say it because they have different sizes. So that's why we cannot add them. In other words, you can see these 5 parts, each of them has a smaller size. To make things easier, I'll just say I have 5 smaller slices plus 3 big slices. How many slices do I get? I get 8 big slices or 8 small slices? Neither, because we cannot add them. They don't have the same size. So that's the first thing we have to do. We use what we learned in chapter 2. We can convert any fraction to their equivalent fractions. And in order to make sure they have the same size, instead of 2 different sizes, 1/6 and 1/4, we just need to turn 6, the denominator, 6 and 4, to a common number. And by multiplying, remember when we convert fractions into equivalent fractions, we multiply. So we are going to multiply both numbers to some kind of numbers. We end up with the same number. Notice that if we multiply 2 here and 3 here, we end up with the same number, 12, which is called the LCD. Okay, so why do we need a common denominator? Because with different denominators, they have different sizes. We cannot add them. But after we convert them to the same denominator, 12, now let's see the process. So for the first fraction, we multiply both top and bottom by 2, which means in the drawing, we divide each of this part right here. Maybe use this color. So each of these parts, the smaller parts, into another 2 parts. So if you look at what they did here, so each of those becomes these 2. And the second one becomes these 2. The third one becomes these 2. The fourth one becomes these 2. The fifth one becomes these 2. Even the one we didn't take, we're also going to turn that into the same size, becomes these 2. But for the bottom one, and we're going to this piece, for this piece, we're going to turn, notice we multiply by 3. So we're going to cut this into 3 equal sides. So one slice is turned into 3 slices. So we have 1, 2, 3. And the next becomes, probably should also use this color. So this next slice it becomes 1, 2, 3. And next slice becomes 1, 2, 3. And the next slice becomes 1, 2, 3. They also added the other parts from the 5, 6 to here. You could do this way, or you could, this might be a little, I guess, you could do it a different way. So I probably would. So let's see here. Let me clear this. So you can take this and cut. So what they cut that into 2 equal parts, and cut this one into 3 equal parts. Because for the first one we multiply by 2 and 2. That's why we only need to cut it into 2 equal parts. But for the bottom one, we multiply by 3, so we need to divide it into 3 equal parts. But after we do that, and then you look at this picture right here. So all of them will be turned into the same size, 1 over 12. They sort of shared the same picture, because they're going to be turned into the same size. But you could do them with two different pictures. And next, what they did is, so they took five of these, so it slid down to right here, and then they took 3 of these and added to that. So 3 parts. This is 3/4 here. So this is 5/6, and that part is 3/4 when you add them. And again, notice that with the original size, we cannot add them because this is way smaller than that. So what we do is, so you could also do what the textbook example did. So you're gonna turn each of these into 2 slices. So one of them becomes these 2, one of these becomes these 2, one of these becomes these 2, and this one becomes these 2, and this one becomes these 2. And then for the bigger part, you have to multiply by 3, so which means each of them becomes 1, 2, 3. This becomes 1, 2, 3. This becomes 1, 2, 3. So now when you add all of them together, if you look at the final picture, all of them have the same sizes. Now comparing to the original, this one right here. So right here they have different sizes. The blue ones and the orange ones, they don't have the same size. But now all the blue ones and all the orange ones, they're turning into the same size, so we can add them. Okay, so you can see here why we give them common denominator, because if so now this is turned into 10 parts size of 1/12. So this is the 10 parts right here, 10 parts of size 1/12. And the bottom one is turned into 9 parts of size 1/12. See, originally 6 and 4, different sizes. Now 1/12, 1/12, same size. So these is going to be turned into 9 parts of 1/12. So now we can add them. So you can count, we have 10 of these, 10 twelfths, 9 twelfths together, it's 19 twelfths. So notice 1/12 gives us the size of each part. So we have, you count how many parts we have. We have 19 parts. What's the size of each part? It's 1/12. And that's again the definition of fraction, because the definition of fraction says the top number tells us how many parts we have. The bottom tells us the size of each part. So, and notice when we add these slices, the size doesn't change. So that's why the 12 stays as 12. We cannot add a 12 and 12 to get 24, because when you combine the slices, the size doesn't change. So how do we, first of all, we explain why we have to get a common denominator, because we want them to have the like parts or equal size parts. Secondly, how do we explain the process of adding? So you can use, for example, 5/6 of a pie, and then we get another 3/4 of the same size pie, or pizza. You can use pizza. So now we are going to convert them to the like pieces, as seen in the drawing. So the total amount of pie we have now is 10 parts of each of size 1/12 plus 9 parts each of size 1/12. So together we have 19 and 12 twelfths. If you want to convert to improper mixed number, that's 1 and 7/12. So we have 1 pie plus 7/12 of the pie. Now, in the next few problems, we're going to learn how to convert improper fraction to a mixed fraction, a mixed number.